Here we go. Hi, it's Keith Townsend from the CTO Advisor with a, hybrid. This is something that I used to do all the time over on virtualizedgeek.com, have these tech talks. If you're watching this, you might have found this via the post I just did on the CTOadvisor.com talking about architects and troubleshooting high-level systems or distributed systems. The distributed system that I gave an example of was an IP webcast system. Very, very complex set of problems, very high risk from a business perspective, a lot of attention the project received. That was, I think, a great insight into what it functionally means to be an architect. I think this is more of for the geeks who were curious as to what the exact technical problem was, what was the solution, and how did we get there. Let's have that discussion. So let's draw out what we had going on from a technology perspective. So if you read the blog post, you read that basically I had two different video sources. One was a studio, and the other one was a HD teleconference video solution. And this studio had a connection to a network encoder, a video encoder, basically a codec that converted the analog signal into a digital signal that our system could interface with. That got connected to, via a network, a media server, that media server connected over a 1 gigabit connection to our enterprise data center. And then at our enterprise data center, we had our network, which was basically the network core. We'll just skip to the network core. The network core was a pair of Cisco 7Ks. And then from there, we went to a web server. And then from the web server, we went out to the WAN, which was by the way, a frame. I didn't put it in the notes. This is frame relay. Couldn't remember. Actually, it wasn't. I can't remember if it was frame relay or ATM. I'm getting old. And then from there, we went out to various sites, including back to the studio, which had a bunch of participants watching in their data centers or in their different offices. And then we had roughly 85 WAN sites. And in these WAN sites, the configuration was pretty typical. We had a Cisco 6509 class closet switch for terminating the connection. Obviously, not terminating the connection, obviously we had different edge routers there, but the symptoms were pretty much all the same, so it really doesn't matter. And then this HD connection might have been a remote site with a hanging off a 65, we'll just simplify it, a 6509. And a bunch of end users there as well. So relatively simple concept. From the two video sources, we combined those. The WAN fed it back to the DC. At the DC we had the media encoder, which encoded the media, sent it to the web server would feed it back out to the WAN, and then to the locations. Video at this age isn't complex. In 2012, this is circa 2012, we knew how to do video. and prioritize video. If you remember, if you're a networking guy, you remember there was a rush to do QoS everywhere. This was probably circa 2009 when everyone was saying, you know what, QoS all the way to the edge. That idea had just started dying down, and we've started to apply QoS where it made sense versus QoS at the 6509s, QoS in the data center. That it just became a nightmare to manage from a configuration perspective. It also was subjective. What was called QoS on a switch versus what's QoS on a router, what techniques are you using to implement QoS? That wasn't, QoS was more of an art than it was a defined science. The problem that we were encountering was that video, if I'm at a remote site and I connect to this web server via IP, just pure TCP IP, unicast, I had a great viewing experience. However, if I'm going to serve video to 12,000 workstations in an enterprise over T1, anything ranging from a T1 all the way up to a DS3, I don't have enough bandwidth to send all that video traffic via IP. I'm going to use a multicast technology in an enterprise. This is the advantage of enterprise class network. I control the network for the most part, and if I want to use multicast to have a simultaneous viewing experience, multicast is most definitely a great option. It limits the amount of IP traffic that traverses the network, and more or less everyone should have a pretty good viewing experience. So what we experienced is that in workstations in the DC, video more or less was fine. When it hit the DC and it went out to the closet switches that were in the same physical network as the DC, everything seemed to be fine. At headquarters, where we would have to traverse back over the WAN, the experience wasn't good. But however, it was extremely, this 1 gigabit connection, if I did IP cast over that network, everything was fine. So that told us that the problem was most definitely probably in the network. However, if you read the blog post, you knew we got an awful lot of attention when it came to this problem. So we needed to attack it from a bunch of different areas. We contacted several people, from our media encoder folks to Cisco to the WAN provider. We got the desktop team involved. We got the company that made our interface for our web application involved. We brought all these folks to kind of a troubleshooting war room session over, and this is over a couple of months. This is not a one-time event. Started to dig in it. The Cisco, we paid a good amount of money for a Cisco consultant to come in and tell us that our 6509s are configured correctly. Our edge devices are configured directly for multicast. They looked at, there was no packet overruns on the routers. There was no packet overruns on the closet edge switches. The encoder guys would come in and say, you know what, the encoders are not breaking a sweat. You guys are really not doing anything special. This is HD video. You're doing standard 420p video. So these problems you're seeing, we shouldn't be seeing them. It's probably in the network. Again, we kept drilling down the team. In our troubleshooting sessions, basically, we gear up for these big town hall events, these huge multicast sessions. One of our biggest challenges was reproducing the problem in a test environment. Since we're using Windows Media Server to serve out the content, and we were also using Windows Media Player to consume the content, ultimately it was an embedded player. How do you generate that much traffic kind of ad hoc? We could have, we tried a ton of things. We had a couple of people at each site run video. So, from a pure multicast, if the video is making it over the WAN and trying to eliminate the WAN as a bottleneck, we had just folks at as many sites as we could, start up the video, and you know what, this stressed the system at the most to about 50 sites. So if 50 sites could simultaneously pull video over multicast and the experience was good, you know, that's when we kind of started to scratch our heads. We couldn't see packet loss. We couldn't see drops on the edge routers, on the Cisco closet switches. We just couldn't replicate the problem until one of the engineers came up with a bright idea. He used a OpNet, it's a network agent, to actually spin up media player, Windows Server, on all the workstations in the enterprise. So we actually had as many as 12,000 machines, as many of the machines that were left, kick up the web interface to this application, start streaming, and start seeing where it broke. So we could successfully recreate the problem, which is a critical portion of troubleshooting a distributed system, is to be, or any system, is to be able to recreate the problem. We were finally able to recreate the problem, but the secondary problem that we had is that we still didn't know why. The data that our systems were giving us didn't tell us what the problem was. When we looked at our network equipment, when we looked at the workstations, the systems seemed in range of, in the performance range that you would expect for multicast. There was no packet overruns. CPU utilization on the edge routers and the 6509s were fine. Everything looked great. Until one of the smarter engineers, and these are all smart guys, noticed a pattern that the stuttering and the poor video quality only happened during rapid movement on the video. So if you know anything about video encoding, if you do what's called constant bit rate versus variable bit rate, there's a trade-off between the two. In constant bit rate broadcasting, I can create a constant kind of size of my packets, size and shape of my packets, and even out the traffic. In variable bit, the disadvantage to that is that traffic use is inefficient. So if I'm sending this whiteboard picture and this whiteboard picture doesn't change, then that's a waste of bandwidth. I should never resend this image if this portion of the image doesn't change. Constant bit rate would constantly send this whiteboard image over and over again, inefficient use of space, but consistent. Variable bit rate would only send the changes to the video. So as my arm is moving in this video, variable bit rate would send that traffic over. So when we saw either camera movement, rapid change in the presenters, that's when we noticed that there was a problem with video performance. So that would lend us to say that somewhere, either the network, the encoders, something isn't handling that rate of change. Ultimately, what we've discovered what it was is that the 6509s were getting overrun. If you think about what happens when you do multicasting, you create a packet, that single packet is copied across all the ports on the destination switch for the users who were consuming. What we discovered is that when we entered one of these variable bit rate spikes, the 6509s would not be able to copy all the multicast packets at one time. Solution: replace all the 6509s. Not realistic. 6509s were already ultra expensive closet switches, and replacing them just weren't an option over 85 sites. And then this problem also experienced itself in lower class switches where we had 3500 series switches. It was a consistent problem throughout the Cisco universe. What we ended up doing was we put a 3590, I forget the model of switch, but basically what the switch did was it could take that variable bit rate knock it down into fragments that were basically buffer the transmission of those high utilization, or that those spikes, and basically smooth out those spikes, send it over the WAN. And when the edge switches received those multicast packets, they were brought in at a bit rate that the switches could actually handle to reproduce. Problem solved. We won the day. We saved the contract. Blase, blase, blase. That's not the important part. The important part is that when you troubleshoot a distributed system like this, you have to understand all the different bottlenecks, the points of pain, the attributes of the application. So in this case, we're talking about IP video. This could happen to any application, not just IP video. It could be SAP, telephony, anything that has a certain characteristic. We need to understand those characteristics, what could impact the performance of the application, and how do we measure, in the other pieces, how do we measure kind of success. So throughout this whole process, we developed all of those processes for how to troubleshoot IP multicast video. Extremely difficult from a technical perspective, extremely difficult from a business and political perspective, but one of the more rewarding troubleshooting events of my career. I'll forever remember this design. I'll forever remember the experience and the guys on the team that helped make it happen. That's it for this pseudo tech talk. I actually enjoyed doing a tech talk for the first time in a long time. Follow me on the Twitters. I'm at CTO Advisor, and on the web I'm thectoadvisor.com. Thanks.